when you are thinking about composition function, think about you have two paper bag. You put one bag inside another bag, and then the double layer bag is a composition function. Two bags, two paper bags, A and B, you put A inside B, or you put B inside A. So that is called composition function. So in algebra, we have function f and function g. So the FOG of x, that is, you put function g inside function f. So the way we read this, do you see this? FOG, that is called f of g. And then the GOF, that is called g of f of x. So you put function f inside function g. So let me draw a picture for you. So let's say we have function f. So let me draw a box right here. And this box stands for function f. And then for function, we have domain and range, right? So domain is the input. So let's say we have domain x, and then we input that to the function. So let's say f of x is equals to x plus 1. When x is equals to 5, you put the 5 in. So 5 plus 1 is equals to 6. Then 6 is your output, right? So you have f, and then you input x in there. So the output, you get f of x, right? So you insert x into f, and then the output is f of x. Now I am going to put the whole thing inside another function. So I grab this output and then treat that as an input, and then I input that to function g. So this is function g. You input the whole thing to function g. So now the output is g of f of x. So just like you have one paper bag, you put that paper bag inside another paper bag, and then after the process is done, you have a double layer paper bag. But how do we handle this in algebra? So before we get into that, other than f of g and g of f, we can also have a f of f, so which is f of x. So we put f into itself, and then g of g. So this is g of x. We put function g inside itself. So we have f of g, g of f of f, and g of g. You see these four all the time. So let's say we have two functions. So let's do that in a different color. So let's say f of x is equals to 5 divided by x minus 1, and then g of x is equals to, let's say, ln x, natural log function. All right, let's try the f of g. So the f of g of x, so this is f, you put function g inside f, and then you have f. What is function g? Function g is ln x, then you replace g with ln x. So f of x was 5 divided by the independent variable minus 1, right? You replace x with ln x, then in the body of the function, you don't write x anymore, you write ln x. All right, so this is f of g. And then for f of g, so let's do something fun. How about the domain of f of g? The domain of f of g, so this is, we have a denominator, right? So first of all, we have ln, so we have to say that for ln, for this ln, x has to be greater than 0, right? This is for the ln, so for ln x. Do you remember that ln1 is equals to ln1 is equals to 0, right? And then is other than x greater than 0, is there any other way to get a 0 in the denominator? If ln x is equals to 1, then we have a trouble, right? Do you still remember ln of what is equals to 1? The answer is ln e is equals to 1, right? So other than x greater than 0, we have to emphasize that x cannot be equal to e, and e is about 2.7. So when you write the domain, so here is the domain. So we have 0, and then the e right here. So we have to take out the e, and then 0 greater than 0, but we have to skip over e. So that means this is from 0 to e, and then from e to positive infinity. So that is the domain of f of g. And then for the function f and function g, so for function f itself, what is the domain? The domain is x can be everything except 1, right? And then for g, x has to be greater than 0. But when you put one function inside another, that changes the domain. Okay, so we just finished f of g. So what about g of f? So let's do g of f. So we have g of f of x. So this is g, and then you put f inside g. So this is g of what is function f? Function f is phi divided by x minus 1. So g was ln, the independent variable, right? So now you replace the independent variable with phi divided by x minus 1. Alright, so this is a ln of something. So first of all, I see a rational function inside ln, so I have to immediately say that x minus 1 cannot be equal to 0, so x cannot be equal to 1. And then what else? So since you have ln, you have to mention that the entire quantity inside the ln parenthesis has to be greater than 0, because ln negative and ln 0, they are undefined. Think about the graph of ln. ln 0 is a vertical asymptote, and then ln negative is totally undefined. Okay, so we have to say that phi divided by x minus 1 has to be greater than 0. So one number divided by another number must be positive. That means phi is already positive. As long as the denominator is positive, the whole thing must be greater than 0, right? Okay, so that means x minus 1 has to be greater than 0. As long as the denominator is positive, phi divided by positive is absolutely positive, right? And then what's next? The next step is x has to be greater than 1. So we have to include this not equal to 1 and has to be greater than 1. Okay, and then the domain is, we draw a line, 1 not equal to 1 and greater than 1. So that's it. So that will be 1 to positive infinity. So that is g of f. What about f of f? So let's change to another color. Let's do f of f. So we have f of x. So we put function f inside itself. And then function f is phi divided by x minus 1. And then for the original function f, that is phi divided by the independent variable minus 1, and then you already changed the independent variable to phi divided by x minus 1. Alright, then you put the phi divided by x minus 1 in there. If you don't need to do any more works, then you can stop over there, but if you want to find the domain, then you have to clean up the denominator. So this is phi divided by phi x minus 1, and then we write the 1 as x minus 1 divided by x minus 1. So you have phi divided by, so this is x minus 1, then you have phi minus x, look, minus x, and then you minus the whole factor, so that will be phi minus x plus 1, right? So what is phi plus 1? Phi plus 1 is equals to 6, so let's erase the phi and the plus 1, so phi plus 1 is just equals to 6, then we put a 6 in there. And then you flip the x minus 1 to the top, so you have phi divided by 6 minus x, and then you multiply x minus 1. And then let's find the domain. So this is f of x. The function is already there. Let's find the domain. The domain is, you have to look at the denominator and say that 6 minus x cannot be equal to 0, so x cannot be equal to 6. That's the domain. X can be any number you want except 6, so we draw a line. 6, it can be this side or this side. So from negative infinity to 6, and then from 6 to positive infinity. Let's do the g of g. So the g of g, we change to another color. So g of x. So that is g of x. And then the g of x is ln, right? And then g was ln x, but you replace the ln x with ln x. So you have ln x inside itself. So this is the g of g. And then for the domain, you have to emphasize that x has to be greater than 0. And then for the number line, so draw 0, x greater than that. And then the interval is from 0 to positive infinity. So that is the basic of composition function and finding the domain. That's the end of this video. If you think my instruction is helpful and clear, Give me a like, share the video for me, click the subscribe button if you are on your way out. I will catch you all in the next lesson.